Good day everyone. Today we will look at Chapter 8, Conic Sections. At the end of this course, you should be able to identify and write the standard and general equation of circle, parabola, and ellipse. You should be able also to sketch the graph of circle, parabola, and ellipse. And you will be given some application in the end, and you should be able to solve it. What are conic sections? Conic sections are curves that result from the intersection of a plane and a double cone. But since we are not covering hyperbola, so I'll be using a single cone as an illustration. Let us look at how a conic section in a shape of a circle generated. The section here is a circle. Next, we will look at an ellipse. This section is an ellipse. Next, we will look at parabola. This section is a parabola. The general equation of any conic section can be written as this. And we will learn how to identify the general equation of a circle, an ellipse, and also a parabola. For general equation of a circle, we can observe that both x and y are squared. And also the coefficient of the squared x and the squared y are both the same and the sign are positive. General equation of ellipse, both x and y are squared. However, the coefficient of the squared x and the squared y are different. However, both are positive. For parabola, only either x or y is squared. We have seen the general equations of circle, ellipse, and parabola. So these are the standard equations. For circle, both squared and denominator 1. For ellipse, we still can see the square. However, they have different denominators. And for parabola, only either one is squared. And it is very important to observe that for ellipse, it will always be equals to 1, and we have to write the denominator in squared form. For parabola, it is very significant to write the side without the square to be in a multiple of 4. And for circle, everything must be in squared form. Right? So now let us look at example 1. Determine the type of conic sections of the following equations, and by completing the square, rewrite the equations in standard form. First question. Observe that x and y are both squared, and we can see that their coefficients is the same. So this is definitely a circle. Second question, both x and y are squared. However, they have different coefficients. So this is ellipse. Third one, only x is squared. So this one is parabola. So this is the general equation of a circle given to us, and we are required to rewrite this so that it will be in standard form. And we will be completing the square method to solve this. So the first thing we need to do is to group all the x together and all the y together. And the constant, we bring it to the other side. Alright, so to be able to have a complete square, we need to find a value for this, and we need to find a value for this one. And this value is actually just to balance up whatever value we add up to this side. So what are the values? So the value here, we can find it by taking half of -6, which is -3, and square of -3 is 9. Whereas this one, half of 10 is 5, and square of 5 is 25. So this is what we get. 9 and 25. And we cannot just simply add values to this side without balancing it to the other side. So 9 plus 25 is equals to 34. So now we can factorize this one and we get a complete square. Same goes to this one, we get a complete square here. But for a standard form, we are required to write everything in squared. So 36, we have to write it as 6 to the power of 2. The reason for this is that so that we'll be able to identify what is the radius and what is the center of the circle. We will learn about that later. So this is the general equation of ellipse. We're going to rewrite this into standard form, and again we'll be using the completing the square method. So just like what we did before, the first thing we need to do is to group all the x and all the y together and bringing the constant to the other side. However, since the coefficient of x squared is not 1, same goes to this one, we have to factor them out so that it will be easier for us to complete the square here. So factor out 4. This, now we get -8. Factor out 9, so now we have -6. So we need to find the value here to complete the square. Same goes to this one, and it is half n square. So half n square of -8 is 16. Half n square of -6 is 9. And this value here is just to balance all the value that we add up at this side. But be careful, because it's not just simply 16 plus 9, but it will be 16 plus 4. Sorry, 16 times 4 plus 9 times 9. So it will add up to 145. We factorize this, we'll get a complete square, which is x minus 4 to the power of 2. And this, when we factorize this, we get y minus 3 to the power of 2. Don't forget the coefficient, the factor. We continue. The standard equation of ellipse required that this side must always be equals to 1. Therefore, we have to divide everything by 36. So this is what we get. We get the denominator 9 and also 4. Again, that the standard equation must require us to write this in squared form. This is actually just to make it easier for us to identify the major axis and the minor axis. Major axis is the longer diameter and minor axis the shorter diameter. And this will tell us the center of ellipse, which is coordinate 4, 3. But we will learn more about that later. Last question is general equation of a parabola. We can identify it by looking at this. Only x is squared. So the first thing we need to do is to group all the x together. Since y is without the square, so we bring it to the other side. And we need to complete the square for this one. So similar to what we have done before, we take half and square of this. So the value is 4, and we can now complete the square of this one by factoring it. We factor out the 8, and we have to write this in a multiple of 4. So this is the standard equation of a parabola. We will see the significance of why we need to write this in the multiple of 4 later on. That's it for today. Thank you, and have a nice day, everyone. Bye.